What are we talking about today? So, some of them are really, really, really easy. Okay? X squared plus 7x plus 12 equals 0. How would I solve that? It's a trinomial, right? With a leading coefficient of 1. So do you think you might be inclined to factor it to try to solve it? AC is 12. B is 7. What multiplies to be 12 and adds to be 7? 3 and 4. So I could go straight to my factors. X plus 3, x plus 4 equals 0. Yes? Guys, if we have two numbers that are being multiplied together and that equals 0, what has to be true about one of these numbers? It has to be 0, right? That's the only way you can multiply numbers and get an answer of 0 is if at least one of them is 0, right? Well, which one? Well, they both could be, couldn't they? We have to take into account both of them being equal to 0 because both values would make this top equation 0, right? So I have to take each factor and set it equal to 0 and solve each factor separately, but each factor, yes? So x equals negative 3, x equals negative 4. Some of them are really easy like that, right? What about this one? Oh, there's 4 terms. That's no problem, right? I'll just factor by grouping. So I'm going to think about this in my head real quick. X squared is common. Don't write anything down yet, please. Remember, we're thinking about it in our head. If I factor out an x squared, what am I left with? X plus 1, right? What am I going to factor out of here so that my parentheses is x plus 1? Uh-oh. Do you remember when we first started factoring by grouping? I said, if there's 4 terms, we want to try factoring by grouping. Can we always factor by grouping? No, but all the ones we did that day and the next day, we could factor by grouping, right? And I said one day, we won't be able to factor by grouping. Today is the one day. Okay? So let me just tell you this. We'll go back to this example real quick, and I'll say, if it's asking you to solve it, try to factor it. If you can factor it, set the factors equal to 0. Here's your solutions. It's as easy as that, right? Whether it's 3 terms or 4 terms, because can you factor sometimes by grouping? Yeah, absolutely. Factor by grouping, set them equal to 0 and solve. There's your solutions. Okay? I'm not going to do a bunch of examples of those because it seems fairly obvious, even to you guys right now, how you could do that, right? What you need to see is problems like this. Okay? But before you can see a problem like this, there's something you need to know. And that something is called the rational root theorem. And I want you to write down the rational root theorem without panicking. Okay? Rational root theorem. It's funny that you say that about my handwriting because they told me last period they couldn't read it. Yeah. They couldn't understand that said if. I'm not judging them. Maybe you're right. Maybe they just don't read cursive very well. Okay, remember what I said. I want you to write it down without freaking out. You can do it. I know you can do it. Okay? Just write it down, and then we're going to talk about it. Oh, I have it right beside me. I wrote that by memory. But the words, I'm making sure I get the words right. But thanks for thinking I could. Okay, you got it? Almost? Okay, I'll wait. So the rational root theorem says if a function, we're going to come back and talk about this in a second, okay? If a function has integer coefficients, is that hard to understand? If a function has integer coefficients, what does it mean by integer? -2, +5. If it has integer coefficients, then every rational solution where that function equals 0 has the following form. Okay? Have I read anything that you don't understand yet? You just panicked because there was a bunch of math words all together, right? I don't want you to panic. I'm going to show you the mathematical definitions of stuff sometimes because I need you to be able to calmly read through the definition and know what's going on. Is that fair? Okay, so let's start back at the beginning. If this function, now all this function says is that it has a leading coefficient and it has x to the n. That means that that's going to be the highest exponent. Because what's the next highest exponent? 1 less than that, right? And then 1 less than that and 1 less than that, and then a to the... Oh, I wrote these backwards. Can you fix it? Please forgive me. This should be a 2, and this should be a 2. Not there, not there. And, oh, Jiminy Christmas. Well, I told you I wrote it by memory, and looks like I should have looked at this one too. Okay? A sub 2 x squared. Right? So we start with the highest exponent. The next one is the next highest. 1 less than that. And then we get to x squared, and then we get to x to the first, and then we get to the constant. Does that make sense now? I think maybe you would have understood it a little bit better if I would have written it correctly. I'm sorry. Okay? Does that make more sense? So if this function has integer coefficients, then all the possible rational solutions to make this function equal to 0 look like this. All the factors of the constant, this one, divided by all the factors of the leading coefficient. We usually talk about P over Q. Why P and Q? I have no idea. Just because that's the letters we usually use. Got it? So now, what's the best way to try to understand a definition? Do an example, right? Okay, so let's come here. Right now, if I said, what are all the possible factors? you have an infinite number. Can I try to make that number a little smaller? Okay, we're going to do that by finding the factors of the constant divided by the factors of the leading coefficient. So looking at this problem, what are the factors of the constant? So 1, 3, 5, and 15. You got that okay? Can I argue with you for a second? So if I have to make 15, do you agree that 1 times 15 is 15? Do you agree that 3 times 5 is 15? Do you agree that negative 1 times negative 15 is 15? So not only do I have to take into account the positives, I have to take into account the negatives. You okay with that? Then I have to divide that by all the factors of the leading coefficient. Well, what's the leading coefficient in this problem? So I have to take into the factors, I have to take into the possibilities the factors of 1, which is 1, right? Why did I go ahead and write plus or minus? Always positives and negatives, right? Because if I ended up with a negative 15 on top, I could divide that by a negative 1 and still get a positive 15, couldn't I? So I'm just trying to cover all my bases, right? Well, what happens when I divide all the numbers at the top by a positive 1? So plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15. What happens when I divide all the numbers in the numerator by negative 1? Yeah, but didn't I just take that into account by putting plus and minus already? Right? Because if I have a positive 1 and divide it by negative, that's negative 1, but I already wrote that. You okay with that? So instead of having an infinite number of possibilities, now I have 8. You okay with that? Now, I'm going to show you a way to do this that's not going to be the way we're actually going to do it, but it's a way to do it. And I just want you to appreciate the way we're going to do it in just a second. You okay with that? Do you remember when we did synthetic division and long division? And I said, how are you going to know if something's a factor? In synthetic division and long division, I told you specifically there was a time where you would know it was a factor. And that time was when the remainder was 0. That's exactly right. Okay? So let's try to find a factor by doing synthetic division. Now, how many how many factors of this problem should I get? What's the highest exponent? 3. That's how many solutions I should get. Factors. Okay? My highest exponent tells me there's a thing called the fundamental theorem of algebra that says whatever your highest exponent is, that's how many solutions you should get. If it's called the fundamental theorem of algebra, I think that's probably pretty important, right? Okay? So that tells you how many times you need to do synthetic division to find a solution. Well, it may not be 3 times. I need to get 3 zeros as my remainder, right? So where do you want to start? 1, okay. 1, negative 17, and 15. And what should I be getting in this box right here? A 0, right? That's my remainder box. 1, 2, 2, negative 15, negative 15. Oh my gosh, we got so lucky on the first time. So now we have 1. How many more do I need? 2. What do you want to try next? 2? 3? Okay, 3. Pretend that's a 3. 1, negative 17, 15. 1, 2. Oops, what did I do wrong? Do you see it? 1, 3. This is a 4. This is a 12. This is a negative 5. Oh my gosh. We are so lucky. How many more do I need? 1 more. Okay, what do you want to try next? 5, okay. 1, 1, negative 17, 15. 1, 5, 6, 30, 13. Uh-oh. Do I even need to finish this? No, it's going to be a positive number. That's not going to be 0, is it? Okay, what do you want to try next? 15. Okay. 1, 1, negative 17, 15. 1, 15, 16. Uh-oh. What? 15 times 16? What's 15 times 16? $240? Do I need to keep going? No. That's not going to be 0, is it? Okay, what do you want to try now? Negative 5. Okay. Why are we trying negative 5? Because Cohen said, right? We're just guessing. 1, 1, negative 17, 15. 1, negative 5, negative 4, 20, 3. Oh my goodness. So here's my question. I haven't done negative 1 or negative 3 or negative 15. Do I need to do them? Why not? We have 3, right? We already have our 3 answers. So here's something we need to talk about real quick. Okay? You need to be able to tell me the factors, and you need to be able to tell me the zeros. Okay? Looking back at the first problem we did, right here, I need you to know that this row right here, these are the factors. And this is the zeros. You got it? So how do we get from this work to my factors and my zeros? Because of how we did this work, the zeros are actually easier to see. What are my zeros in this problem? 1, 3, and negative 5. We know the zeros. How do we go back to find the factors? So x minus 1, x minus 3, and x plus 5. Always before we get to our factors first, right? And we set them equal to 0 to solve. So some people, you remember, some people when we talked about this, it's like, oh, you just have the opposite sign. And I said that works most of the time, right? Unless you have a multiplier in front of the x and then it's a mess. So we just have to be careful about that, right? But here's my zeros, here's my factors, here's my zeros. Yes? So that's a way you could do it. Can I show you a faster way? Okay. Let's do another example then, and I'll show you a faster way. What do you want to do first? So we would combine like terms if I could write the example right. Thank you, smarty pants. Find the factors of what? 30 divided by 1, right? Factors of 1. So what are the factors of 30? 1 and 30, right? 2 and 15. 3 and 10. 4. No, 4 doesn't work, right? 5 and 6. All divided by 1. So this is P over Q. What does P over Q end up equaling? Well, everything divided by 1, right? So 1, 2, 3, 5, 6, 10, 15, and 30. Geez, that's a whole lot more to try than the 8 that we had on the last problem, right? But it's better than infinity, isn't it? So what do you want to try first? 1, okay. 1, negative 10, 19, and 30. What are we hoping for? A 0 in my remainder box, right? 1, 1, negative 9, negative 9, 1, 1, negative 9, negative 9, 10, 10, dang, negative 1, 1, negative 10, 19, 30. 1, negative 1, negative 11, 11, 30. So nice. How many more do I need to find? So we're going to work smarter now. Remember I told you I was going to teach you a faster way? So we're going to go right here. Would you please convert this answer back into algebra? X squared minus 11x plus 30. Guys, can you factor that? What is it? AC is 30, B is negative 11. What multiplies to be 30 and adds to be negative 11? Negative 6 and negative 5? Well, there's 2 of my factors. What's my other one? X what? Plus 1. Here's my factors. What about my zeros? How do we get the zeros again? I literally set it equal to 0, right? So if I added 6 on both sides, what would I get? 6. If I added 5 on both sides, what would I get? If I subtracted 1 on both sides, what would I get? These are my zeros. Wasn't that so much faster? Wouldn't it be nice if there was a faster way? Write the problem down and I'll show you the faster way, okay? So before I show you the faster way, I want to go back to this problem real quick. Everybody have that one written down? I want to go back to this problem real quick and remind you what we just got for our factors and our zeros. And at the same time, I want to show you the graph of that function. What do you notice? Where's the graph crossing the x-axis? Negative 1, 5, and 6. Oh my gosh. Negative 1, 5, and 6. So if we're doing this problem right here, Liz, I'll answer that question right now. Why are we not always putting this in the calculator? I'll answer it right here. Okay? So you're starting a graph and you're putting that equation into the graph. Okay? 3x raised to the third minus 25x plus 58 squared plus 58x minus 40. I just want you to look at the graph for right now. Okay? You don't put equal 0 because if you hit tab, it's already f of x equals. Okay? We're using our knowledge of graphing of zeros on the graph and of zeros when solving an equation. Is that fair? Okay? So before we do anything with the graph, I need you to tell me all the possible factors that we could be doing synthetic division with first. What are all the factors of 40? 1 and 40, 2 and 20, 3, no, it doesn't work, 4 and 10, 5 and 8, so 10, 20, and 40, right? All divided by what? What are the factors of 3? 1 and 3. So this is already different this time, isn't it? Everything in the numerator divided by 1 is just everything in the numerator, right? So plus or minus 1, 2, 4, 5, 8, 10, 20, and 40. But guys, we also have to divide everything in the numerator by 3, right? So also we have 1/3. Also we have 2/3, 4/3, 5/3, 8/3, 10/3, 20/3, and 40/3. Woo! So first of all, aren't you glad I'm using this problem to teach you an easier way? Yes. But second of all, as long as this list isn't it still shorter than infinity? Because that's my other option, right? Now, look at the graph. Can you assume anything about the graph? We're assuming. We don't do that, do we? Okay. Where does it look like it crosses the x-axis? 2 and 5, right? Is there a way we can tell for sure that it's crossing at 2 and crossing at 5? There is. We could do Control T. What does that give us? The table. And if we're looking at the table, is there a way we can be sure it's crossing at 2 and 5? How are we sure it's crossing at 2 and 5? The y is 0, right? Isn't that what we're trying to find, guys? Yeah. So we know for sure x is 2 and x is 5. How many answers should I be getting, though? 3. Do we know where else it's crossing? No matter if I go up or down, I'm not finding another 0. Are you finding another 0? No. It's a good thing we know another way to find it, don't we? How do we find it? Yeah. Synthetic division. We already know what to use, though. We're not guessing. We already know what to use. Which one do you want to start with, 2 or 5? 2. 3, negative 25, 58, and negative 40. And I have to show you the part that I think is the funnest in just a second when we get there. I'm just foreshadowing for you. There's a fun part, in my opinion, coming up. You ready? 3, 6. What is it? Negative 19. Multiply. Negative 38. 20. 40. 0. We knew it should have been 0, right? Okay? Here's the fun part that I think is cool. Guys, if 2 and 5 are factors of this, they're also factors of this. So I can keep going right here. My remainder box is under the constant again, right? So it's just over 1 for my remainder box. 3, 15, negative 4, negative 20, 0. We need our factors, and we need our zeros. Yes? We already know 2 of the zeros, right? I already know 2 and 5. I'm trying to find the third one. But what does this tell me right here? God bless you. That tells me 3x minus 4, doesn't it? What are my other 2 factors while I'm here? Minus 2. Very good. So I need my third 0 from this factor. 3x minus 4 equals 0, right? Set it equal to 0 and solve. Good job. Add 4 on both sides. 3x equals 4. How do I solve it? Divide by 3. X equals? That's my third 0. Do you see why I couldn't see it on the table? Yeah, the table only counts in integers, right? Okay. Questions? Well, the way that it's set up right now, it only counts in integers. So on your homework problems, just to be clear, here's what I want on your work, okay? You're going to have to read the directions to know if it wants you to enter the factors or the zeros as answers into the computer part, right? But on your work, I want the problem. I want all of the possible factors, just like we wrote here, okay? I want at least one synthetic division problem. Here we could do 2 to find the third, but I want at least 1. Guys, because what's going to happen? Can you look in the calculator and sometimes see all 3? You can, okay? What are we practicing here? Synthetic division, okay? So take these and do at least one synthetic division problem. Tell me the factors and the zeros. Got it? Any questions?